All right, what's happening, my mathletes? That's right, Miss Muscarella coming at you. And in this video, we're going to take a look at inverse trig function composition. So let's grab our notes, our unit circle, and let's go. Now, if you notice on these examples, they both kind of start out the same way, right? 4, 5, and 6 are like find the exact value. Same thing with numbers 7, 8, 9. Find the exact problem. Now, we always want to start with the inside function and kind of work to the outside function. But here's what I really want you to focus in on. The inside function on all of these, for 4, 5, and 6, all three of those are an inverse trig function. Whereas on the numbers 7, 8, and 9, the inverse trig function is on the outside. So when you're solving an inverse trig function, your answer for that piece will always be theta equals then some angle. Now, on the other hand, the tangent or secant or sine, or still sine right there, and sine again, and cosine. So anytime you have one of the trig functions, your answer is going to be a ratio. Because remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and so on and so forth. So anytime you're finding the answer for a problem that involves sine, cos, tan, the reciprocal of sine, cos, or tan, your answer is always going to be a ratio. All right, so let's kind of work from inside to out here. And this is where, when you're dealing with number 1 here, or number 4, when you take a look at that, the arc sine of the arc sine of 1/2. So you have to remember the domain restriction for arc sine, right? And that's that quadrant 1 and quadrant 4. But remember, it goes from negative pi over 2 to pi over 2. So within that arena, I've got to figure out the sine value. That gives me an answer of 1/2. So what angle? So that piece right there, the sine of some angle is going to be 1/2. Well, the sine value is the y value is positive, so I know that that's going to have to be in quadrant number 1. So the value that is, so theta, my angle, is going to be, and this is where, again, you got to have the unit circle memorized. But if you forget that, you can always draw that reference triangle, yeah? So let's just kind of zoom in here on this piece. So the reference triangle, and I always kind of draw them like this. I'm like, all right, if I put 30 there, then 1, 2, square root of 3, that would be the reference triangle for that, using special right triangles. And I want the sine to be 1/2. Remember, sine is opposite over hypotenuse. And that, my friends, is this value right here at 30, because that's opposite, that's hypotenuse. So the value of that in terms of radians, 30 degrees, is pi over 6. So that's the first piece that we have to do, yeah? Now the second part, now I've got to find the tangent of what I just found, because all of that, you know, arc sine of 1/2, that value is pi over 6. So what we have to do next is find the tangent of pi over 6. Now, we know the tangent of pi over 6. So, again, this is where pi over 6, that's 30 degrees tangent, is opposite over adjacent. And I'm sure you have your unit circle memorized. So, you're not going to say 1 over square root of 3. You're going to say root 3 over 3. So, that would be the solution for this type of problem. Now, a common mistake that we'll see students make is at the end, instead of just leaving it as at that ratio, they'll be like, oh, theta equals root 3 over 3. No, don't do that, man. That's wrong. That's incorrect notation. It's poor form, and it's just simply going to cost you a point. So don't be that person. So your final answer is just this piece right here. That's it. Tangent of pi over 6 is root 3 over 3. You're done. If you write theta equals, minus 1 point for you. So be careful. Don't be that person. Now let's take a look at number 5, shall we? Because number 5, like on the first one, arc sine of 1/2, that was on the unit circle. On number 5, 4/3, not on the unit circle, bro. So now I still have to kind of remember the domain restriction for arc tangent. And again, that's quadrants 1 and 4. So in this case, I have to analyze two things. Thing number 1 is, what is the sine, S-I-G-N, what is the sine of 4/3? That's positive, and tangent is positive up in quadrant number 1. So we will draw a reference triangle up in quadrant number 1. Now tangent is opposite over hypotenuse, or opposite over adjacent, so the opposite is 4 and the adjacent is 3. So I don't have to worry about adding a negative sign to either one of those two values. Now this happens to be a Pythagorean triple, which is really nice. But in case you got stuck and you're like, ooh, I don't remember what that is, you can always use, so this would be r. So r is going to be, 3 squared plus 4 squared, square rooted. And when we do that, we'll have 9 plus 16, which gives us 25. When we square root 25, we're going to get 5. So this value right here would be 5. So the arctangent of 4/3. So I got to draw this triangle to figure out what that is. Once I get to that piece, now I'm just like, okay, I got to find the secant of that triangle that we just drew now that we know all 3 sides. Now, a lot of people think about secant in reference to cosine. So if you're thinking, all right, the cosine of this angle, this arctangent, this triangle that we just found, the cosine of that would be 3/5, yeah? Which means the secant would be the reciprocal of 3/5, which is 5/3. So that's how you do this type of problema. All right, that's how you do that type of problem. Number 6, same thing, not something on the unit circle, but on the domain restriction for arc cosine. Remember here, we're up in quadrants 1 or 2. Now, arc cosine is negative, which means cosine is the x-coordinate, so we've got to be in quadrant number 2. So with that said, I'm going to draw my reference triangle. Boop, boop. Cosine is adjacent over hypotenuse, so 5 goes there, 13 goes there. Now I got to figure out where to put the negative sign. And the x-coordinate is negative in quadrant 2, so that would go there. Now the missing side, again, a Pythagorean triple, so this side is going to be 12. So I want the sine of this angle, and the sine of theta would just be 12/13. You're done. Boomskis. Now, let's take a look at the other values. So these ones, 4, 5, and 6, your answer is going to be a ratio. Now the answers for 7, 8, 9 are going to be angles. So when you do this, make sure that you're finding and notating. So the notation is going to be what's really, really key here. So we're going to bring the unit circle in here so we can have that kind of, there's our reference as we go to get ready to play with these things. So check this out, right? The inside function on number 4, so let's just kind of bring that to light there. So cosine of 5 pi over 4. All right, so we go to the unit circle. 5 pi over 4 has a value of, the cosine is going to be the x-coordinate, which is negative root 2/2. All right, so now I've got so this piece, so now we're going to have arc sine of negative root 2/2. That's going to be my angle. So the sine of, or the arc sine, oops, forgot the little arc sine. So the arc sine of negative root 2/2. So I've got to figure out, all right, the sine of some angle is going to give me negative root 2/2. So I want the y-coordinate to be negative root 2/2. Now, again, I got to pay attention to the arc sine domain restriction, and that's going to be quadrants 1 and 2. Since the y value is negative, that is going to be in quadrant number 4. Now, here's a common mistake on this one. So a lot of people do this, just kind of make this mistake. Because they'll look on their unit circle, they're like, okay, I got this. Negative root 2/2, that's down here at 7 pi over 4. Cool. But the domain restriction means you can't go around that way and come to 7 pi over 4. So you've got to rename it as negative 1 pi over 4. And as our good friend Arshdeep said, instead of calling it 7 pi over 4, it's like just knock the 7 off and make that value negative. So the answer to this problem is theta equals negative pi over 4. All right, same idea here for, let's just go ahead and do number 9. We'll skip number 8. We'll go right to number 9. So with sine of 7 pi over 6, so I want to look on the unit circle. Where's 7 pi over 6? Cool. We want the sine of that value, which is the y-coordinate. So at 7 pi over 6, I find the y value, that's negative 1/2. So now I want the cosine, the arc cosine of negative 1/2. That is going to be theta, my angle. So some angle has that value, an x-coordinate, where that's negative 1/2. So theta is going to be, again, the value on the unit circle. So cosine of theta is going to be negative 1/2. But again, because we're dealing with arc cosine, we're dealing with quadrants 1 or 2. And where's the x-coordinate? Going to be negative 1/2, and that, my dear friends, is going to be at 2 pi over 3. So theta would have a value of 2 pi over 3. All right, so that is going to be a little bit different piece on this. So each one of these, and this is where we're going to be really picky, make sure that you get your notation correct, because the answer for questions like 4, 5, and 6 is going to be a ratio, and the answers for questions 7, 8, and 9 are going to be angles. All right, that's it for this video. Thank you guys for watching. Hopefully that clarifies some things on that, and you guys are great. And as always, make it a wonderful day, because you guys are amazing. You're awesome. And I'll catch up with you soon. Peace out, Cub Scouts. Love you guys.